The National Electrical Code, or NEC, does not specify a maximum number of non-metallic sheath cables, also known as NMB, that can be bundled in a 2-inch Romex connector. However, Section 334.80 of the NEC requires that raceways, cables, and other equipment shall not be used in a manner that can result in overheating beyond their rated capacity. If it can be demonstrated that the bundled cables exceed the ampacity or fill rating of the Romex connector, it could be considered a fire hazard. This determination would require a calculation or testing. In general, approximately 12 to 15 NMB cables can fit in a 2-inch connector. However, a licensed electrician should assess the specific installation to ensure compliance with NEC requirements. Regarding the number of devices on a circuit, the NEC does not specify a maximum number of devices that can be connected to a single circuit. Article 210.11 of the NEC states that the maximum load on a branch circuit shall not exceed the rating of the circuit. The load calculations performed by an electrician would determine if the combined amperage of all devices on the circuit exceeds the circuit's amperage rating. If the load calculations indicate that the circuit will be overloaded, additional circuits should be added. It is not unusual to have 10 outlets and 4 lights on a single 20-amp circuit, as long as the total load does not exceed 80% of the circuit's ampacity, which is 16 amps. Here's a more detailed look at the factors involved in determining whether your wiring configuration is safe and compliant. Firstly, consider the ampacity of the conductors. The size of the NMB cable, such as 12/2 or 10/3, determines its ampacity. For example, 12 American wire gauge, or AUG, copper conductors typically have an ampacity of 20 amps, while 10 AWG copper conductors typically have an ampacity of 30 amps. These ampacities are based on specific insulation types and insulation conditions, as outlined in NEC Table 310.16. Secondly, examine the dirtying factors. When multiple current-carrying conductors are bundled together, their ampacity must be derated to prevent overheating. NEC Table 310.15. The tray provides adjustment factors for conductors in a raceway or cable. If more than 3 current-carrying conductors are bundled, the ampacity of each conductor must be reduced according to the table. For example, if there are 10 current-carrying conductors, the ampacity must be reduced to 50% of its original value. Thirdly, evaluate the connector fill. While the NEC doesn't provide specific fill limits for Romex connectors, it's important to ensure the connector is not overfilled, which could lead to overheating. The connector should be appropriately sized for the number and size of cables entering it. Check the manufacturer's specifications for the connector to ensure it is suitable for the application. Fourthly, calculate the load on the 20-amp circuit. To determine if 10 outlets and 4 lights are too many for a 20-amp circuit, calculate the total load. Each outlet is typically calculated at 180 volt amps according to NEC 220.14. So 10 outlets would be 1800 volt amps. For the lights, determine the wattage of each light and add them up. For example, if each light is 75 watts, then 4 lights would be 300 watts, or 300 volt amps. The total load would be 1800 volt amps plus 300 volt amps, equaling 2100 volt amps. Fifthly, assess the branch circuit load. Divide the total volt amps by the voltage of the circuit, typically 120 volts in a residential setting, to find the current in amps. In this case, 2100 volt amps divided by 120 volts equals 17.5 amps. This is within the 80% limit of a 20 amp circuit, which is 16 amps. However, this calculation assumes that all outlets and lights are being used simultaneously at their maximum load, which is often not the case. Sixthly, consider the continuous load. If the load is considered continuous, meaning it operates for 3 hours or more, the circuit should not be loaded to more than 80% of its rating. In this case, the maximum continuous load on a 20 amp circuit is 16 amps. If the calculated load exceeds this limit, the circuit needs to be split. Seventhly, address the voltage drop. Excessive voltage drop can cause appliances and lights to operate inefficiently and can damage equipment. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% overall. To calculate voltage drop, you need to know the length of the circuit, the wire size, and the load current. Eighthly, review the applicable NEC articles. Relevant articles in the NEC include Article 210, which covers branch circuits, Article 220, which covers load calculations, and Article 310, which covers conductors for general wiring. These articles provide detailed requirements for conductor ampacity, directing factors, and load calculations. Ninthly, obtain professional evaluation. Due to the complexities of electrical installations and the potential for misinterpretation of the NEC, it is always recommended to consult with a licensed electrician. A professional can assess the specific installation, perform accurate load calculations, and ensure compliance with all applicable codes and standards. Tenthly, document the installation. Keep a record of all electrical work performed, including wiring diagrams, load calculations, and inspection reports. This documentation can be useful for future reference and for demonstrating compliance with the NEC. In conclusion, while the NEC does not specify a maximum number of NMB cables in a 2-inch Romex connector or a maximum number of devices on the circuit, it is essential to ensure that the installation is safe and compliant with all applicable codes and standards. Careful attention should be paid to conductor ampacity, directing factors, connector fill, load calculations, voltage drop, and other relevant factors. Consulting with a licensed electrician is highly recommended to ensure that the installation is performed correctly and safely. Therefore, based on the information provided, it is not clear whether the installation is safe and compliant with the NEC. It is highly recommended to consult with a licensed electrician to have the installation inspected and evaluated. Remember, electrical work can be dangerous if not performed correctly, so it's always best to seek professional assistance.